Hello and welcome to the WattWise demo today. This is our next generation data center sustainability intelligence layer, which is built on DataBricks. The technology stack that we have used here on DataBricks overall platform is first we created a SQL warehouse, then we created the schema inside it, then we built an ingestion framework, then we loaded data into the schema using the ingestion framework. Then we created certain custom views, and then we defined the agents layer. If we show you the platform, then this is the warehouse, and then you can see we created this schema here on that, and there are total 21 objects, 8 base tables, and rest are views. Then we created a CSV ingestion framework on which we are able to ingest data into, and there are 4 modes for inserting, overwriting, merging, and auto discovering. In case the table is not in the schema, it will create automatically. Then we created certain agents, right? And these agents have all different purpose, and they run with a certain set of objective inside. So as you can see on this slide, there are 4 key areas. One is sustainability, one is infrastructure, another is finance, and finally customer. We have total 6 agents. They work on separate views. As a principle, none of them have access to core data. They are all running on views. They don't have any edit access. And the last one, WattWise operation, that is basically a master agent that can run on any views. Basically, it is for edge analysis and more end-to-end analysis, while the other ones are domain specific with a certain intent. Now we will jump into the demo, and for demo we have selected these ones. One is the Queensland Olympic, one is NSW solar diversion, and we will have few ones on. We have created an interesting agent mixer app where we can query multiple agents together on a certain question on a conversational interface and get incremental outcomes from them. It's a more drag and drop kind of agent mixer. Then we will also show agent NLP interface on WattWise operations, where we have created a use case to view. And of course, you will see that DataBricks dashboards for the other use cases. We shall look at some of the dashboards. The first one is NSW solar diversion analysis. And that creates a model where we are projecting a 20% increase in the power consumption at the Sydney Clyde facility, which will add about 94 kilowatt of annual demand to the current baseline of 470 kilowatt hour. What we find is that the current solar generation will only cover about 26% of that demand, additional demand, and you will need a huge grid dependency still about 74% to come from the traditional energy sources. However, there are some recommended actions that can take care of it, how to meet the demand in a blended manner. The next one is the QLD energy projection for the Brisbane 2032 Olympic, based on the historical pattern of last 5 years, including the COVID dip in demand, and then year-on-year projection increase of around 14% year-on-year. We do appreciate that up till 2032, there will be a lot of infrastructure build, so you'll see some more increase in the demand. And based on the projection, what we see is that even if we increase the demand and the solar generation by up to 354%, there will be a huge gap to be met by the traditional grid dependent power sources. In this use case, we are asking customer reporting agent to tell us which customers are consuming most energy across regions. It asks us to filter the question, and after we do that, it gives a more contextualized answer, right? And in the second use case, we blend 2 agents together. One is cost, another carbon management. And we ask one question. They give us 2 different answers. The second one asking us to refine the question a bit more. When we do that, it gives us a more contextual answer based on the real data. In this use case, we are blending energy efficiency and cost optimization agents to give a contextual answer based on their specialty. And they come back with energy efficiency agent focusing more on the PUE improvement potential, while the cost optimization one comes back as the greatest carbon priority, and so based on solar score, strong candidate for solar deployment to reduce cost and emissions. Finally, we are showcasing the outcome of WattWise operations agent on a NLP interface. It is creating the carbon footprint reduction strategy per region by bringing in 3 different reduction interventions: solar deployment, cooling efficiency, post consultation, and then it is giving a phase prioritization roadmap by region. Finally, it is saying what should be the key actions taken per region and the key success factor in therein.